connect remotely. So I'm not sure if I introduced myself last time. My name is Edward Akinji. I'm Assistant Director of IT Infrastructure here at Marshall. I manage the data center, and my group is responsible for server hardware, storage, performance, any infrastructure systems. And I didn't know exactly what level should we talk. Should we start high level and go a little deeper? Or I know that many of you guys already have extensive experience with Linux, so I don't want to be very high level. But at the same time, since this is 101, usually it starts with what is what is Linux. So the operating system started. I think it was founded in 1991. Linus Torvalds from he was a Finnish student or grad student, and he built an operating system based on Minix OS, which is a Unix derivative. It's a lightweight operating system. It's open source. Those are the main issues that operating systems have. And they're open source. Anything it's built on is open source, and it's completely free. I put a link at the bottom of the slide. I will send the PDF file of this slide to everyone on the list. If you go to that link, you will see the email messages that Linus sent it when he announced that he started to build the operating system, which is pretty neat. One thing for non-Linux users, Linux is growing, the market share is growing, specifically on the servers. Gartner research in December 2008 found out that 28% of the servers are Linux. And I think it's growing. I think it's more than 30%. At Marshall here, we have already 30% Linux servers. Now on desktops, it's relatively new. It's a little complicated for most of the users. So it's only 1% of web clients that's based on a web browser, and 92% is Windows desktops and about 6% Mac. I couldn't resist to put those in. A lot of Linux users are against Microsoft and the Windows, and that's one of the reasons why they go, and they are very enthusiastic to build Linux. So it's built from the community, and there's no single company endorsing Linux. But actually, this is an even better one about anti-Windows, and I couldn't resist to put this one. The top distribution based on distrowatch.com currently are Ubuntu, Fedora. Many of you are familiar with those. Open source, very easy to install and use. But also Debian is on the list, and CentOS. Those are the major distributions. In the enterprise, Red Hat and Novell SUSE are the almost 90% of enterprise. Linux is one of those two companies. We at Marshall, we have all our servers are Red Hat. What enterprise services include, those companies, they don't add on top of the code. They take the same code that is available for the public, but they provide support. They provide management tools, centralized management tools that is crucial in data centers and enterprise, and interoperability with other existing enterprise applications. SUSE 2 years ago made a good deal with Microsoft to integrate a lot of components with Microsoft Windows. So you can log into SUSE with Windows username and password. You can add it to the domain. You can centrally manage the servers and send patches through Windows tools. Talking about 101, what is mostly Linux used in the world? There are a lot of popular applications that started and are commonly supported on Linux. Apache web server is 65% web servers in the world are Apache, according to Netcraft. MySQL is an open source database server that is primarily on Linux. There are ports for Windows and other operating systems, but it's primarily made to run on Linux. Perl, PHP, Python, all those scripting tools and development tools primarily run on Linux, and all the developers that developed those tools started on Linux, and it's included with a lot of distributions out of the box. And embedded devices, including firewalls, routers, even TiVo, some phones now, the Android and Google Nexus One, they are a Linux kernel with a modified application on top of it. And recently, you can see Linux to be a good desktop replacement, laptops and specifically netbooks, because they're lightweight and they're free. They are a good option for netbooks. In my team, I have 2 people who, in the last 12 years, never used other than Linux for their desktops for their daily work. I think one of the topics that we can talk about is how to connect to Linux from a non-Linux machine. Many of you are already familiar with Secure Shell, but SSH is the most common way to connect to Linux boxes. OpenSSH is the server piece that needs to be installed on any Linux server to be able to connect to it with SSH, and not a lot of distributions come with OpenSSH package installed. So if you install a new Linux distribution on a machine, you try to connect with SSH, it may not work because it needs OpenSSH. And I will quickly touch on how to install packages in Linux later today. Also, it needs another component on the client. You need an SSH client installed on the desktops that you're connecting from. And also show how to download PuTTY, which is the most common for Windows. And I think macOS comes specifically, I think since macOS X9, it comes with OpenSSH client installed out of the box. The reason why SSH is the most common because it's secure and it's encrypted. Telnet was a one way that a lot of people were used to. It's not as secure as SSH, and it's definitely not encrypted. And also, it's very high performing tool to connect and run remotely code on a Linux box. One thing good to mention is how Linux file system is. Those who are familiar with Windows, there is FAT, FAT32, NTFS. On Linux, there are ext2, 3, and recently there is a ext4 under development. It's the extended file system. What that provides from advantages is the journaling, which is basically storing the file changes and even the metadata in the journal before it gets committed to the file system. And the H-tree indexing, which is it's a kind of a B-tree way of indexing the hierarchical file system structure. Also allows maximum file size of 2 terabytes and maximum file system size to 32 terabytes. So you can have a file system on a machine with the local drives of up to 32 terabytes in one file system. The disadvantages are there is no transparent compression. Those who use NTFS, you can right-click and make it compress transparently to the user. You can't have that. It's not very easy to recover files once they are deleted. And there is no tool other than third-party patches and some hacks that will allow you to defragment ext3 file system. Although it's a little more efficient than NTFS and FAT32 in fragmenting. Before I go quickly in some of the commands, is there any questions so far? And feel free to interrupt me. I think that's part of the live presentation is that you can stop me anytime. I think Wimba allows you to even raise a hand and stop the presenter. The most file system commands that's been used, of course, if you want to list directory, use ls. To change directory, cd. And to remove a file, you can do rm. And if you want to remove a directory, you have to put a recursive -r. I could show some of those live on a VM running here. But it's good to have them archived in the PDF file later. The CP to copy a file, and then if you can, most of the file system and most of Linux is based on text files. Config files are pure text files, and user files, of course, text files. So you will see as you use it more and more, you rely on viewing the files and editing them from the command prompt. Cat, more or less, are the common tools to view the file content. I can quickly switch and see if you guys can you see my screen with Ubuntu desktop? And that's another thing about Wimba. Even though you can't use Linux to connect to Wimba unless somebody already found a way to hack it, but we can. Since I share my own computer, I can go to live virtual machine or remote desktop to a Windows, Linux, Mac, or any other application and show people within Wimba. So those are the basic commands. ls will do a directory list. Copy. I just copied the file.copy. Remove the file. It's pretty straightforward. Once you memorize the commands, it's easy to manipulate files. One thing that is very useful and you need it on an almost daily basis is to know how file permissions work in Linux. It's POSIX compliant, which is what Unix and Mac OS use for file directory permissions. There are two notations. One of them is the symbolic notation. It's very easy to understand. For any file, you have three types of users. You have user, group, and other. So those are tags to any file. If you can see at the bottom of the screen, a file called file. When I list that file, it shows me that it has 10 symbolic notations at the beginning of the file. The first one is what type of file is that, and the dash here means it's a regular file. It's not a directory, it's not a symbolic link, it's a regular file. And then the first three letters, R, W, X, in this example, are for the user. And I made everything here in red means the user, anything in green is group, and anything in yellow is other, which is the word. So for the file called file here, I have RWX for the user, which is read, write, execute permission. So the user add, if you can see here, I don't know if you can see the mouse moving, but here add is the user, admins is the group. So RWX is the permission of add on the file. RX, which is read and execute only, is the group admin's permission on the file, and no one else has any access. There is no other permission on that file. This is a typical permission also in general. If you have your own user file, your username will be here listed as yes, you are the owner of that file, you are the user of that file, and usually you will have read, write, execute permission on the file. And then there is a group that you are a member of usually, and you can change the group ownership of that file to someone else, some other group, and that group here in this case has RX, which is read and execute, and no one else can access that file. For those who haven't used it in the past, it sounds a little complicated, but once you get used to it, it's really easy to understand. The other notation is the octal notation, where it's numbers. Once you understand this list at the top of how things get translated from octal to symbolic, you would know how those numbers work. And I have put example at the bottom, read, write, execute for the user, write, execute for the group, and write, execute for other is 755. Once you also memorize and get used to that, you will find it as many Linux users, it's easier to use the octal notation or the numbers to set permissions. This is an example of what tools need to use to change the file permissions. So if you want to change ownership on a file to the user Edward, you just put chown, which is change owner, the username, and then the file, which will change ownership for that file from whoever was the previous owner to the user Edward. And if you want to change permission on the file, you can choose change mode, and you can either put group plus W, which will give write permission to the group, or you can put change mode to the octal notation, which is 774, which will give the same permissions to that file. Again, for those who haven't used it, it might be a little complicated. Once you get to play around with it and try it, it's pretty straightforward. And you can also change group ownership of a file by this command, change group. Any question on permissions and file system so far? Okay. One thing that for a standard Linux user or somebody who just got started on Linux, you will need to install packages. You may download Ubuntu, Fedora, or one of those distributions, install them on an old machine, but then you go and try to SSH to it. You can't because it needs a package. You try to put a web server, you don't have a web server installed out of the box, you need to install it. So the easiest way is to run the commands that are common in the Fedora and the Red Hat flavor of distributions, which is yum. So you put yum install and the package name, that will automatically install the package. In Ubuntu and Debian, and their derivatives, it's apt-get install and the package name. I can show you a quick example. Usually some examples will help. Apt-get install Apache. I think I already have Apache installed. And the commands are not only useful because they can install the package for you, but they also resolve dependencies, which is very common challenge for other. If you want to install tools without resolving dependencies, it's a little challenging. So this example here, I put apt-get install Apache 2, and it found that there are some packages that need to be installed before that package can be running. So it found those, and it automatically selected them, and I have highlighted those on the screen. Also, it suggested other packages, documentations, and other tools that will suggest to be installed. And if the package is already installed, it will also upgrade the packages to the latest. And it will tell you summary at the bottom, will give you how much storage do you need for those packages to be installed, and it will give you confirmation yes or no. I'm trying to be quick here, but you stop me and let me know if I'm skimming too fast or I'm going too high or too low. Another thing that you may need to do on a Linux box is to start the services or stop the services. And in the flavor of Red Hat, Fedora, CentOS, it's on the command prompt. You go and put service, space, service name, start, stop, restart. This is how typically you will start a service. So if you want to start a service called Apache 2, which is a web server, you'll say you put on the command prompt service space Apache or Apache 2 and start to start it. On Ubuntu, you'll have to go to the etc ent directory and then find the service name there and then put space start. I can show you a quick example. If I want to start, or actually I can check on Apache 2 status, and it will tell me what is the status of Apache. So I put the service name, status, and it told me Apache is running, and it gave me the process ID. If I want to stop it, I put, ITSI, ENT, D Apache, and then I'll put here stop, and it's stopping the web server. Usually the web server will take an extra second or two to stop. If I want to start it, I put ITSI, ENT, D / Apache 2 space start, and it starts the, couldn't be restarted. This is an old VM. So those are the typical ways to start services and stop them on different flavors. If you want to start writing the code, some code to be compiled or edit a text file, there are a lot of text editors installed on a Linux. The most common, the one that you can find in any Linux distribution, and even if you don't install additional packages, you should find VI editor installed. It's an old, I think it goes back to the BSD time when Unix BSD was the most common, and it's widely used. It has 2 modes. It's a little tricky for those who haven't used it. If anybody's used to the Word editor or high-level tools, you may find it a little difficult. But once you get used to it, I know a lot of people who runs development in the command line. It's more efficient, faster, and it's intuitive. But basically, you just need to know a few things. You have 2 modes: the insert mode and the normal mode. Normal is when you run command. Insert is when you actually type or append a text file. I think somebody mentioned the compilers on Linux. I just put a couple of lines about the GCC compiler. It's an open source, most common open source compiler. It supports C, C++, Objective-C, Fortran, Java, and a few others. And if you want to know more about it, it's gcc.gnu.org. Many of you know what GNU is, but it's a recursive of GNU is not Unix, and it's one of the ways Linux hackers like to do stuff. They have recursive namings and crazy way of calling things, but it's also cool and interesting. This is sample code. We can actually try it if you want. It's small code that for those who haven't tried this in the past, it can be good to go back to this slide, take that code, write it in a Linux. All you need to do, put VI in the command prompt, space, hello, or any file you want to call, and then you type those in there. This is the basic hello word, but I changed the word to put my name in there because I like computers to talk with me. And then you go and put G++-wall hello, or whatever the file name, and it will compile it, and then you can run it by ./hello, which will reference the file in the same folder. Now, we already talked about how to install packages, so if you go and put G++ and it says G++ cannot find or it's not installed, you know how to go and do yum install G++ or apt-get install G++ to install it, which is good exercise. And if you run it and you can't run it because it doesn't have execute permission, you already know from, I think, slide 12, how to set permissions to make it executable, which is +X. And we can run that exercise if we get some time at the end. This is some further reading. I'd like to put them in the slideshow if somebody wants to go and read more about it. Yeah, I'm going to put a few minutes for questions. I know we try to meet the hour, so I try to be concise in what included, but we can also spend the next few minutes to talk about any topic in Linux and share experiences if anybody has some things to share here. So anybody has a question?
You got the most important command, but man.
Right, yeah.
Help.
If you need any help for any command, let's say we want to help on the command cp. So if I don't know what cp does, I can put man, which will open the manual page about cp, and it will open the manual page for the cp command. And one of the challenges here, many people are not used to read those man pages. They find it a little overwhelming, but it's the best way to understand a lot about it. Of course, in the early days when internet was not available for a lot of people, man was the way to go and read about it. Now, if I want to know a little more about a command, I will go to Google and search it.
What's the most common distro for HPC?
I think for HPC, it doesn't really. I think there is a distro for HPC that comes bundled with the distribution. I think it's called Cluster OS. But what we're going to be using here, which is the most common way, you get your favorite distribution. A lot recommend enterprise level distributions, which is Red Hat or SUSE and sometimes Debian. What we're going to have here is CentOS, because it's the same code base of Red Hat, but it's free and open source. But ROX is the HPC cluster management tool that we're going to be using. So it doesn't matter exactly what distribution you have. You need to install the packages and configure them. I think ROX is the most common open source cluster management system. But I think I read that there are, and I'm not an expert in that area, if anybody has a better answer, please jump in. But I think there are some bundled distributions where people put ROX or other cluster management system within the operating system and stripped everything else that they don't need and made it an ISO that can be downloaded and installed and build the nodes. The approach we're going to have, we're going to build CentOS boxes, and then we're going to have a master node that's going to provision those nodes with ROX, the cluster management system. But if anyone else has a little experience or read more about it, please share. Any other question?
You didn't mention anything about the common shell. I guess the default mostly now is bash, but there's also the old the original Bourne shell and the C shell and all those. Is there sort of a recommended shell for HPC environment?
I'm not aware if there is any dependencies or any relationship between the shell and the HPC way of work.
Working with NPI and things like that is very advantage to one of the others.
I'm not sure. I don't know. I think the most common is bash, Bourne bash. But I think unless you have your own scripts, bash scripts, or some shell scripting that you use to provision the cluster node or to schedule the jobs, I don't think there is a lower level relationship.
Yes, you talked about packages. So you first download those packages to certain location, then you could install using YUM.
YUM can actually go out to the internet to the basic repositories that are supported, and you can change those repositories to be either community provided repositories. You can go to YUM configs and the etc config, and you can change the repositories, add more if you want to support additional community-based repositories, or you can point it to a local repository. Like in university, if we have hundreds and thousands of Linux machines that we want to manage, we can use our own repository.
Okay.
And this way you can put your own codes or packages, and if you configure all the machines to touch that repository, download the packages, and let's say you build your own codes, you put a package, you host it in our repository or any community repository, anybody can put yum install the package name,
Sure.
and it will download it. And if you have dependencies in your code or in your program on other packages, it will resolve that and will install those additional stuff. But there are also ways to download individual packages. You know, in the flavor of Red Hat, CentOS, Fedora, the most common is RPM, and a lot of developers provide the RPM packages for download. Users will go and download those RPM packages and use RPM command to install or update those packages. But that won't be automatically updated anytime you run the yum update, because the other feature of yum or apt-get is they will go and check what you have already installed. If there is a new package in the repositories, we'll download those and upgrade them. It will ask you first. But if you provide the users with a download link, they will have to come back and check, unless your code itself has some way to go back and check that there is a new release. Also, in Ubuntu and Debian flavors, the .deb is the basic package format that can be installed with IPKG. IPKG is the way to install individual packages.
Thank you.
Trying to mix yum and RPM can be kind of tricky.
We're nearing the hour. Is there any other question or